Welcome to your first video in the Motion in One Dimension unit. After this video, hopefully you will be able to discern between scalar and vector quantities and be able to describe the motion of an object that is moving at constant speed or constant velocity. So two definitions for you to know. Scalar quantities are measurements or values that do not have a direction. So for example, speed. If I say I'm traveling 60 miles per hour, I say I have that speed, but I don't know if I'm going north, east, south, or west. Whereas if I change speed to velocity, I can say I'm going 60 miles per hour east or going 60 miles per hour south. By adding a direction to the speed, I change it to a velocity. Distance has no direction. I can say I'm going 1 mile. But if I'm saying I'm going to go 1 mile south, distance changes into a displacement. Time never has a direction, so it will always be a scalar quantity. And so will temperature. Acceleration and force, we'll talk about a little bit later. They have direction, but we're not going to worry about that today. So let's talk about what we mean about motion in one dimension. Motion describes the placement of an object and the movement of that object from point A to point B, and the action that object took to get there. One dimension just means that that object is moving in one plane or one straight line. So the object would just be moving to the left or to the right, or the object would be going up or down. It's not going to be moving in a curve. So one dimension just means you're in a flat straight line plane. So solving displacement versus distance. So I have an example here of a Furby, and this Furby is going to run a race where Furby's going to go 3 kilometers up, 5 kilometers to the west, to the east or to the right, 3 kilometers to the south or down, and 5 kilometers to the west or to the left. And I'm going to ask myself what's the total distance the Furby travels and what's the total displacement that the Furby travels. So let's see how to solve this. So when I'm talking about distance, distance gets the variable lowercase d. And distance I can just find by adding up all of the distances I run. And I can say 3 plus 5 plus 3 plus 5 makes a total of 16 kilometers. And yes, technically, I round this to 1 sig fig because there's 1 sig fig in each one of these measurements, and that's going to be approximately 20 kilometers. Do these numbers add up to 20? No, but my level of precision says I can only be certain that my distance ran is around 20 kilometers. Now let's do displacement. When I do displacement, I use the variable x. And x, to find that, is going to be from the 3 kilometers going up plus 5 kilometers going to the east or to the right plus 3 kilometers going down plus 5 kilometers going to the left or west. And when I add these all up, all of my directions end up canceling each other out. So my displacement is going to be 0 kilometers. And so whenever I'm doing some sort of race or some sort of event, or if I'm walking around in a circle, my total displacement will always be 0 because my change in position will be 0. So that is the difference between distance and displacement. In this case, let's look at a different case. So we're going to do distance and displacement again, except that we are going to look at it from point A to point C. So Mr. Furby's going to go here, and he's going to go there. So here's the distance. I'm I'm going to go 3 kilometers plus 5 kilometers for a total of 8 kilometers. But now I've got a displacement that's going to be different because the change in position is the shortest along the diagonal, kind of how the crow flies. So the change in position can be found if I consider x being a hypotenuse of a right triangle. So I can say x squared is going to be 5 squared plus 3 squared. It's going to be 25 plus 9. So x is going to be the square root of 34. Not 25, 34. And then if I find this in a decimal, because I have to do decimals because I'm in physics, I get 5.8, but I round this to 1/6 of 6 kilometers. Yes, we know that the square root of 34 is not 6, but we can only be sure that the displacement can be estimated to the one spot, which is 6 kilometers. So there's the difference between distance and displacement with the Furby. One assumption that we made with this Furby is that when the Furby moved up, we considered up to be the positive direction. When the Furby went to the right, we also considered that to be a positive direction. And then when we started canceling stuff out and the Furby moved down we consider to be in the negative direction, and same with when you move to the left. And so one thing that you will always have to do when you are dealing with motion problems is think about a frame of reference. And a frame of reference is just a decision, an object, or if somebody will make that decision for an object, of what the positive direction will be. So we just declared that up was positive, left or to the right was positive, down was negative, to the left was negative. You have to make that decision every single time before you think about a motion problem. On the next screen, there's going to be a couple of equations that I would write down. Let's transfer from distance and displacement to speed and velocity. So speed and velocity is just a distance or displacement divided by time. So for speed, lowercase s is the variable for speed, is the scalar quantity of distance divided by time, whereas for velocity, the vector quantity of velocity is displacement, which is a vector quantity divided by time. The units don't change between these two formulas. The SI units for speed is meters per second, velocity is meters per second. You're not going to always be required to convert back to meters per second, but that's the basic SI unit for each. Distance and displacement both have the units of m, but you could say km or meters or kilometers. It doesn't always require you to revert back to meters. And time is usually in seconds, but sometimes, like you'll see in the next example, that it could be in hours. So here's Mr. Furby again. And let's do the distance, or excuse me, the speed versus velocity for the Furby when the Furby moves all the way around his track. So we found that for distance, the distance was a total of 16 kilometers. So speed is going to be distance divided by time, or 16, oops, I forgot, I needed to round this to correct sig figs, which is 1. And 16 rounds up to 20. 20 kilometers in 2 hours has an estimated speed of 10 kilometers per hour. Now, I could translate this into meters per second by saying 10 kilometers, 1 hour, times 1 hour is 3,600 seconds, times 10 to the third meters in 1 kilometer. And this would turn into 10,000 divided by 3,600, which will get me before sig figs 2.77 repeating, after sig figs approximately 3 meters per second. That is going to be my speed, 3 meters per second. However, let's look at my velocity. My velocity is going to be kind of something interesting. And if anybody does sports where you run around a track or swim in a pool, this is pretty depressing. My velocity is displacement divided by time. Well, guess what? My displacement's 0. 0 kilometers in 2 hours, you have a velocity of 0 kilometers per hour, which quite essentially just tells you you ran around the track and got nowhere. So speed tells you the total distance divided by a time, whereas a velocity tells you how long it took the object to change position. That's the difference there. So hopefully this is going to give you enough information to do the practice worksheets from Physics Classroom that you will find on Schoology. Thank you for watching, and